All right, the time now is 11:28 or 29, Thursday, 2nd of April, 2026. Okay, so today I actually have one interview. So I'll be doing my lead code of the day within 1 hour. And if I can't, I'll just pretty much just brute force through. Okay, so today I'm gonna do something different. I know usually I do the blind 75 questions, right? But today I wanted to do a LRU cache question because this is quite a famous question, yeah? So implement the least recently used cache, LRU cache. The class should support the following operations. LRU cache, initialize the LRU cache of size capacity, get key, so return the value corresponding to the key if the key exists. Otherwise, return -1. Okay. Void put integer key value. So update the value of the key if the key exists. Otherwise, add the key value pair. If the introduction of the new pair causes the cache to exceed its capacity, remove the least recently used key. Okay. Okay. So a key is considered used if a get or put operation is called on it. So this will be the head, so-called head of the LRU cache. So before I begin, I just want to preface this by saying that actually I sort of know that a hash table, hash map is used for O1 get and put. Okay. Uh DLL, doubly linked list, is used to traverse the linked list. It's used to traverse for. Okay, so I just know these two data structures are used, and I'll be so-called going after the hello, hello. Yeah, I'll be going after the we'll be going after we'll just be trying to implement this. So this is a hash table and linked list question and a doubly linked list, and it's a design question. So far I've only really done operator overloading in Python, and that was for another interview. But for now, today I'll be doing LRU cache in JS. Okay, so you should aim for a solution with O1 time for each put and get, and an overall space of ON, where N is the capacity of LRU cache. So basically, it's a ON cache, which gives me a O1 get. That means from the hash table, I should be able to get the key and move it to the top priority. Yeah. And then the other end of the linked list is for me to remove the least recently used. Yeah. So I think first of all, hash is used to do get and put, right? So it's used to store references for A, B pairs. Okay. It's not used to traverse, but used to update the cache for the least recently used part of the question. So So hash-based data structure with unique keys. All right, so const hash is equals to new. So let's see. Sorry, this dot this should be just be a new map. Okay. And then this dot capacity is equals to capacity. And lastly, there should be a doubly linked list. So we can do a class load. Okay. So this dot key. So oops, constructor key value. this dot key equals key, this dot value equals value, this dot next. So I can just do next previous is equals to next. This dot previous is equals to previous. Okay, so let's look at the LRU. Where is it? Okay, so discuss the least recently used item first. So for example, uh, A key value lah. So A0, A0, A. So I use A, B, C, D, A, B, C, D. Then A is the least recently used. So when I access E or whatever, I will use E. Okay. Then after that, I'll use D again. So D becomes the most recently used. Sorry, the least recently used is on the left. Oh, wait. Sorry. This is not the. Okay, so we have a hash table here. Okay, so uh when E is accessed, it's a mist and must be installed in a block. So E will replace A because A has the lowest rank of 0. Okay. In the next to last step, D is accessed. So D has a rank of 5. So if let's say I use F, F will replace B, which is the lowest rank, and then the next one will be C. Hmm. Okay, so let's see. Hash map. Deal with the least recently used criteria. Okay, let's see. Doubly linked list. Update a key. Use a doubly linked list where key value were stored as the nodes. Correct. So key value. And then remove. All right. Cool. So the idea was correct. What we want to do is to have this dot hit goes to null. This dot tail goes to null. Okay. So, so. I need a remove. Right. So remove, remove LRU. This will be a function. Okay. So this is a helper. But how do I remove it in O1 time? Interesting. This one will take in a node. So param node, node. Use previous and next to remove this LRU. Mhm. So I'll take the previous. I'll do a node dot previous dot next is equals to node dot next. Okay, wait, hold on. Font's original previous is equals to node dot prev. Font's original next is equals to node dot next. Okay, then point OP to ON. So original previous dot next is equals to original next. Then original next dot prev is equals to original prev. Okay. Then now the remove LRU is done. So since put is also O1, so this is O1. Okay. And then put is also O1. Put at the head. So if let's say we are removing the least recently used, right? Or removing whatever. Used for updating the rank or eviction. So before this, we need to check. If there is no previous, that means it's the head. And if there's no next, it means there's the last one. If not original prev, that means it's the head. Must be head. Okay. Remove node lah. Don't do remove LRU. Remove node. This dot head equals to original next. Okay. Then original next is equals to null. Dot prev is null. Dot prev is equals to null. Okay. Then we need to do an else if. Else if no original next. Then we'll do this dot tail is equals to original tail. This dot tail is original prev. Original prev dot next is equals to null. Else we will do like this. And yeah, somewhere in the middle. So this is must be tail. Yeah. Cool. Ooh. Okay. So when I remove the node, I have to return, right? Return node. So I need to do what's that? This dot hash dot delete uh the key, node dot key. Yeah. Okay, cool. Cool. Okay, so when I get is I need to remove. So if this not this dot hash dot has key, return -1. Okay. Else I will return key this dot hash dot get key. Yeah. Then I need to move to most recently used. So move it to head. Okay. So this can involve this dot remove uh the node. I need to store the whole node inside. So it's a key. So this one is actually a key to node. Key to node pair. So I store a key to node pair. And then what I'll do is I'll delete this. Okay, blah, blah, blah. I need to pass in the node. So I will do, wait, let's not do this. Const node remove node to move. This goes to this dot remove uh wait, this dot hash dot get. No, yep, this dot hash dot get key. Yep. So I get the key to get the node from my hash table, and then I remove it. Okay. Then after that put it at the front. So now that I have the node, because this remove returns a node, right? Yep, it returns a node. Oh, I think I need to change the documentation style. Oops. All right, awesome. So use previous and next to remove node remove, returns the node removed. Okay, good. So this is of node. Then I will do put. Put will always insert it at the head, I believe. This dot put node to move. Return node to move dot value. Yes, sir. Okay. So get is pretty easy. And now we do put. So put. So this is guaranteed to be present. Okay, let's try. So put is tricky, because if it's the first element, we need to take note. First element, so puts. Puts this into head of LL and hash table. Evicts if full. Holy. Okay. Directly from tail. Okay. So I'm gonna do this dot size. Okay, capacity. This dot size is equal to 0. This dot size plus plus. If this dot size is equals to 0, that is the first element, then const node, added node. Well, I can just do this outside, right? Const added node is equals to new node. Then the key value null null. Right. Then if the first one is 0, then it's the same. I'll just do this dot it is equals to added node. This dot tail is equals to added node as well. We point to the same node. Then wait, hold on. Remove will do this size minus minus. Then this one will be plus plus. What am I doing? Okay. Okay. Then I will add to the hash table as well. So hash table is dot hash dot set key added node. Easy. Okay, then that's it. I do this. Then I return. Okay. Else is uh full already. So the other case is that it's full already. If this dot size is equal to capacity, this dot capacity, then I will evict, then add head. Evict from tail, add the head. So this const evicted node is equals to this dot tail, right? So we'll point to the tail's pointer. Then uh evicted node dot previous dot next is equal to null. Okay, so this node's previous will now point to null. So you have no more next and the tail will shift. This dot tail will be equals to evicted node dot prev. Okay. Then if you still want to put when it's full, you will evict and then you will add to the head. So this dot so this dot head dot previous will be equals to added node. Okay. So the head's previous will equal to added node. Then added node dot next is equals to this dot head. This dot head will be rearranged to added node instead. So this dot head's original head, the previous will point to this new node. Okay, then this guy will connect to here, and then the head will shift. Then we return, because the size doesn't change. Else, this is just a normal put. So we just add to the head. So we just do this dot head dot previous is equals to added node uh this dot added node dot next. Okay, I can just use this part of the code, right? No, it's okay. I'll just copy and paste. Okay. I need to delete this line. Then we'll do a this dot size plus plus. Okay. So cannot set properties of null, setting previous. So LRU cache to put 110. Okay, I'm pretty sure the initialization passes. So we'll console log, okay? Console.log. Constructor. Okay, we do pass the constructor. It should be it says get, right? So put. The problem is at get and remove. Remove, where is remove? Setting previous. Cannot set properties of now. Something previous. Okay. So I will remove first. So it has the key. Right. So node to move. This one is okay. Then we will console.log node. Okay. Let's see what we get. We get the node, the next, and previous are both null. Correct. Because there is only one element. And then if there is no original previous, no original next, it'll go here. Okay. So this is the case where there's only one node. So if there's no original previous, it will do this. So I need to add another case before this. If no original previous and no original next. So this is the only node case. Only node case. I'm pretty sure there is probably going to be something that I missed out. So I'll just do this first. I will just do this dot head was the null, this dot tail was the null. Dot, dot, dot. Okay, cool, good, 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 good. So I'm getting a -1 here. So what's the case? I do put 110, I'll get 1, then I get the value 10. Okay, then I put 220, put 330, okay, and then I get 2. Okay, so let me just change the console logs, okay? So put. So now the put is only every time after it puts, right, I want to console log something. So if it's the first element, it will do this. Size plus plus. Size is capacity? No. So I will do console.log this dot. Okay, let's try. Node What is this? This is interesting. Oh, it's a circular reference. Okay, wait, hold on. Hmm. Okay, that means there is something wrong. So, okay, the added note. Let's do a console.log added note. Oh, wait, why is it like this? Note. The note is a note. The value put. Oh, oh my God. Put takes in a key as well. Oops. Hold up. This is wrong. Okay, so based on this, the note, the key is 1. Okay, so I will call put here. Okay, the added note is normal. This is correct. And then when I get, I will remove it. Oh, let me just console log the note to move, see whether it's correct or wrong. Ah, mm. Okay, so the note to move when I get 1 is this, and then I put it back. Okay. And when I do a put to, what do I need to, what do I need to get it? Put, then I get to. Oh, oh, get to. Okay, this is boop, boop, boop. Eh, why am I passing in the whole? Oh, yeah, okay. Just need to put in the value. Okay, so now the size is 2. I put in 1, and then I get 1. I put in 2. So when I put in 2, after I put in, I will do a console.log this dot size, this dot head. Okay, let's go. 2, and then there's a circular reference. Okay, then I need to solve the circular reference. Node 2's next is pointing to node 1, and node 1's previous is pointing to node 2. This is correct. Then I evicted. Hold up, wait. I put 2, so 2 is the most recent. I need to add n from the head. Put 3. Then I should evict 1. Okay, so console.log evicted node.val. Let's try. If it's 1, then it's wrong. It's undefined. Oh yeah, evicted node. Evicted node is 1. Did I not remove this from the hash? Okay. Then I do this dot. Oh, oh my god, I never update the hash set. Okay, this dot hash dot set dot remove p not p. I need to remove the evicted node dot p. Oh shit. Oh. Oh. Wow. Wow. Okay, this is a very long. Cannot set properties of null setting next in put. So same thing. I'm gonna try. Okay, size 2, put 1, put 2, get 1. Then I put 3, it should be 1 and 3. Get 2, minus 1, correct. Then I put 4. 4 should evict 1, correct. So I get 1 is null. Then I get 3 is also, oh. Huh. Wait, hold up. Cannot set properties of null at next. So it's towards the end that it's wrong. It's just the get 3 and get 4. Remove const console.log node to move is node to move dot value. Let's try 1. Ah, I get 1. Cannot set properties of null, setting next. In the line 99. Line 99. Properties of null. No, I'm pretty sure it's this one. Oh. Evicted node. Huh? Why is okay, hold on. So put one, put two, I get one. And then I put three, it'll evict two. Evict two. Let me try put evict. Evict two for value. Right. Evict two for three, which is correct. Okay. Then I get two. Okay. It's -1. Okay. Then I put four. Evict one for four because three was recently put, which is correct. Then I get one. Get one. Get one is -1. Then get three. I think three is the problem. Okay. This dot hash. Let's try. Oh, hold up. Oh, oh my God. I forgot to set it. Where's the delete? Uh-oh. Okay. I need to set it. This dot hash dot set key added node. Okay, maybe I'll just straight up just set it first. Number 8. Cannot read properties of now. Okay. 2008. Oh my God, this is so long. Get one. Get two. Okay. Get four. There is no four. Put four, which means I'll evict three. Okay, let's run this. Oh shit. Evict three for four, correct. Okay. Then get four, put four, get one. One is still there. One is rank one now. Get two, rank one now. Get three. Three is not there. So 1, 2 minus 1, get 4. 4 is the highest rank, followed by 2, followed by 1. So if I get 2, 2, 4, 1, now it's 2, 4, 1. So I put 1, 8. Okay. Eh? Evict 1 for 8, correct. Oh, hold up. Technically, it should still work now. Added node is key. Okay. Okay, this is too damn long to read. Okay, let's try again. It's because I put 1.8 and it needs to update the value there. So in a sense, it says that I evicted the node of value 1 for this. So we look at the question again. I believe they covered this. Okay. So update the value of the key if the key exists, which is covered by this. Okay. So maybe we just do a edge case, right? So if this dot hash dot has key, right? Then we'll just update. Wait a minute. What is it? Hold up. A dot has. Okay. Console dot log this dot hash dot has. True. Okay, so I put 1837. Then I get 1. Oh man. This is the only difference. Then 271127 minus 1. Minus 1. Oh. Okay, you got this. Oh, of course I'm going to delete it after that. Okay, if this, okay, so in case of key updates only, still need to change position, rank, but don't delete. So if this, if the evicted node dot key is equivalent to key, so if it's not equivalent, then we delete. Oh, come on. Okay, this is a shorter test case. Let's try. Input. So 1, size 1, I'll put 2, 1, I'll get 2. Put 3, 2, will evict. Oh, what is the output? Nothing. Key. Hey, would cannot set properties of null input. Put. Next. So if it's full, This has got to be an edge case, right? Okay. I will evict from tail. Then I evict 2 for 3. Okay. Evicted node whose previous is null. Oh man. Why don't I ever use remove? Wait, I should just use remove, right? Hold up. I need to remove. This dot hash is delete from hash. Is equals to false. Is equals to true. So if delete from hash, then I'll do this. Delete from hash, then what if I just do this dot remove evicted node? Then delete from hash is if I want to delete is key not equals to evicted node dot key. So if it's not equal, then I delete. Oh, now everything is off. Correct what? Dot hit. Hey, key. Okay. If delete, wait, where did I put that? If delete from hash, then I run this. So by default, it's true. So where else did I use remove? Put back. After that, I put. Oh, hold up. Evict two. So I put 1. Okay, let's try again. I put 1, then I put 2. Then I get 1, rank 1. Then I put 3. I'll evict 2 for 3. Then I'll get 2. It's minus 1, correct. Okay. 3 is still the highest rank, so I should remove. Should evict. Yeah. Should evict. I should evict. Okay, never mind. You know what? Sorry. Cannot set properties of null setting next at LRU cache dot put 103. Setting next. So I just probably just do a if evicted node dot previous, meaning that there's something before it. This one equals to regardless. Oh my days. My logic is so off. Okay, so LRU2. Okay, let's use this test case. Oh, okay. 2, get 2 is -1, put 2, 6. Get 1 is -1, put 1, 5. It will evict 2 for 1. Put 1, 2. I won't evict anything. Get 1 will give me 2. Okay. Eh? I'll put 2, 6. I will put 1, 5. Okay. Oh, wait. Hold up. I'll put 2, 6. Then I'll put 1, 5. Then I'll put 1, 2. So if it's full, it'll evict 2 for 1 again. That's not right. Then I'll have 2 ones. And then I'll remove 2. Oh, damn. Okay, if the evicted node. Okay. I need to consider one more case. So the next case, if it's just a simple update, only need to move to here. If, okay, wait, hold up. If this dot hash dot has key, if exists, just move to it. I will dot hash dot set key edit node. Okay. So set key to add a node, and then I will just move it to the head. So I'll do this dot remove. Uh, I'll remove it and then I'll move it to the head. This dot remove remove is what key? I need a node. Okay. Cons original node equals to this dot hash dot get key. So get already moves it to the head. Oh, okay. Okay. No, 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 no. I'm getting confused. Okay, I'll get a node. Okay. Then I will do a remove. This dot remove original node. Okay. Then I remove the original node already. Okay. Okay. This dot remove dot this dot hash dot get. Okay. I'll get the node and then I'll remove it. Then I will put it at the head. Then after that I'll do this dot head is equals to original node dot next is equals to this dot head, this dot head. Okay. Then original node dot prev is equals to null. Then the head dot next. Then after that, head is equals to original node. Then after I return. Oh, this works now. This is the simple case, right? Oh shit. If original node dot prev. Oh dear. Yeah, I do 3, 1, 2, 3, 1, 1, 3, 2 now. And 2, 1, 3 minus 1. Then I'll put 4. I'll evict 3, which is correct. Now I get 1. Get 2, okay. Get 3, will turn minus 1. Get 4. Oh man, the code's getting a bit complex. Okay, just look at the solution now. Okay, I don't want this. Okay. This dot left, this dot right. This dot left. Okay, this is getting a bit too crazy. Okay, let me just do oh class LRU cache. Okay. 算英雄。This dot left is supposed to be 0, 0. Right. Suppose you note 0, 0. Okay. This dot left dot next is supposed to this dot right. This dot right dot prev is supposed to this dot left. Okay. Why do we initialize? Okay, remove note. Okay, insert. Okay, right side is MRU. Okay, okay, get E. So if key not in cache, turn -1. Else remove, insert near right, return value. Put key value. If key exists, remove its old node, create or update the node, and store in cache. If insert right, if length cache, if size greater than capacity, remove LRU, delete P from. Okay, okay, let's just see how they do it. Previous, okay, next. Previous dot next is equals to next dot previous, okay. Then so this will ensure no nulls in ELL. This is handling L. Okay. Then insert. So insert the LRU const prev is equal to stop right dot prev. So previous MRU. So previous MRU dot next is equals to node. Node dot previous is equal to previous MRU. Then node dot next is equals to this dot right marker. Then this dot right dot prev is equals to node. Yeah, so you just insert there. So this one is the previous most MRU. Now this one point to here, then this one points to here. Okay, this one points to here, this one points to here. Okay, and get. So if this dot map, if this dot hash not has e, return -1. Else I do bonds node is equals to remove node is equals to this dot hash dot get key. Then this dot remove node. This dot insert removed node. Insert removed node. Okay. Fetched node. Fetched node. Fetched node. Then return fetched node dot value. Okay. So this is the tough one. So if this dot hash dot has key, this dot remove, I will remove it. This dot hash dot get. Okay. Const new node is equals to new node p value. Then this dot cache dot set key new node p value new node. Then this dot insert new node. Wait, I need an insert. So the helper is remove and insert. If this dot hash dot size greater than this dot cap, const LRU equals to this dot left dot next. Okay, then let's do this on my own. So I will take, okay, I'll point to this dot left dot next, this one. So left is the dummy. Then this dot left dot next is equals to LRU dot next. Yeah. Then LRU dot next dot prev will be equals to this dot left. Yeah. Hash. Oh wait, I forgot to remove. Okay. This dot hash dot delete e. What? Oh, wait. Oh, this was. I need to take a look at this elegant solution again. So this is a buffer for no null handling. Same. So what this does is it creates a buffer where we have two nodes signaling the left and the right end of the double and the queue. Okay. And this left dot next by default is right and right's previous is default left. So they're pointing to each other. So whatever we want to remove, right, we can always ensure that there are no nulls because there is no need to handle the null hell. So previous, so if we want to remove a node, right? So if the hash doesn't have this value, right? If let's say there is no value, I don't do anything. But if not, I will remove. It means that it's inside. I'll remove the node, and then these two will just continue pointing to each other. Yeah. So that was the problem that I was handling, going to handling hell over here. Yep. All right. So that does it for today. I'll see you tomorrow.